Okay, hello, this is Dr. Janes, and today I'm going to show you how to build a high-power ferrite transformer. This one had a very broad bandwidth from low kilohertz to into the megahertz range, and it's a 1-to-1-to-1 transformer, and I'm going to use it for some interesting projects. And seems to be very efficient, very nice transformer, simple to build, and I'm going to show you all the steps to build it. Okay, let's get going. Okay, it looks like it finally arrived, and got our handy dandy razor blade here. Oh, let's see what we got. It comes in a Ziploc bag type thing. Oh, look at that, very cool. Four wires bonded together. Let's see, how can I get the end of this? I think the end's right there. Probably when I undo this, it's going to spring all over the place. Look at that, 4 wires. Excellent. So I'm going to make a mixing transformer, an audio mixing transformer, a high power one. And let's see, I think I'm going to use a big ass ferrite core and start winding it. Okay. And we're going to put a lot of windings on it because, alright, the more windings the better. It's going to have better coupling. And then we'll test out the frequency response of this, and we're going to build some interesting device with this one, I think. Okay. Okay, so here we got our 4-strand wire. And the reason why I want 4 strands is that I'm going to put 3 input signals in, and I want to have one output to my high power speaker. Well, it's over there, and I'm going to build a super high power device that can do 3 tones, and it should be interesting. But before I do that, I want to check the frequency response of this, make sure that it can cover the frequency response range of the speaker at least. And so it should be interesting. Let's start winding this. Now, here's a ferrite, and it's always really fun winding these things, because the way you got to do is you got to plan out how much wire you're going to stick through there, because once you start winding it, see this, you can't wind more onto it, and so I want to put a lot of turns on it. I want to have it be a pretty high coupling, and since we're doing audio frequencies, it's going to need a lot of turns probably to get the reactance up high enough, because you don't want the anyway, you want good coupling, and so you're going to get better coupling. The impedance is going to be higher on both sides of the 1-to-1. It's going to be a 1-to-1 transformer, and I'm going to try to estimate how much wire I need to feed into this before I start. So I might do some experimental windings to see how far around it's going to go, and because I can always start winding this way, and then if it's not going to be enough, I could take some of this and start winding it back the other way. So anyway, it's lots of fun. I'm not going to film me winding this core, but I'm going to fiddle with this a little bit and see if I can figure out about how much windings I want to stick on it, and then we'll do some testing with it. It should be interesting. Okay, so I think I spooled about half of the spool through the inductor, and it's going to be so much fun. I gotta make sure that this is not tangled up, and so if that's not enough, I can start winding back the other way, because I want to put as many windings as I can on this core, make sure it has good frequency response. And like I said, it's the audio frequency range, so you're going to have to put a lot of windings on it to get high impedance at the low end. And I think I'm going to use some electrical tape and tape the wires in place before I start winding it, because that's always good practice. Otherwise you could be halfway through and they'll spring up, and I want the windings to be tight. And I'm going to start winding them flat on here like that, so they make the windings as compact as possible. See how many turns I can get on it. I think I have close to 50 feet spooled through the inductor, and we will see. That's going to be so much fun winding this. Let me tape this up first. Okay, so there we go. I just took some electrical tape and I fed it through the center and kind of taped it down. And I'm going to start, I guess, feeding this wire through, and we'll see how many windings we can get on this guy. Should be interesting. Then we'll test out the frequency response. Hopefully it comes out the way I want it. Should be interesting. Oh, I don't know if I mentioned the diameter of this guy is about 2.5 inches by about 1 inch thick by about 1.2 inches ID. So that's the dimensions of this core. A fairly large core, so it should be able to handle quite a bit of power before it saturates. And like I said, I'm hoping to go up to about 300 watts because we're going to probably use these pyramid speakers here, which are good up to 300 watts and 25 kilohertz. And I want to have a broadband frequency response, so we'll see what this does. Okay, so maybe this is not the best way, but got to start someplace, right? So I'm just feeding a loop through. And I'll just start pulling 50 feet of cable through and try to get it flat afterwards. And how much fun, huh? I'll try not to tangle this thing up. It's like someone said once, how do you eat an elephant? You eat it one bite at a time. How do you wind a toroid or a Tesla coil? One turn at a time. Okay. Okay, there we go. We got our second turn on there. I'm just going to keep on winding this around, pulling this loop through, and we'll see if we can wind this coil up. Okay, so here we go. Got like 1, 2, 3, 4, 5 windings on there, and we'll get another loop going. Start pulling that thing through. Yeah, this is so much fun. Almost as fun as knitting. Oh. And there we go. Make sure it doesn't pull the camera over. Oh, there. I'm gonna have to put this down because it's getting tangled in the camera. Okay, so it looks like I was able to get about 15 turns on the first layer. You can see the inside. Looks very colorful. Okay. And so I guess we'll go around the second layer, and I'll layer the outside turns in between, interstitial between the where the other turns are, and we'll do a second layer and see if we can get 15 on the first layer, maybe close to 15 on the second layer. Should be interesting. Okay, so it looks like the second layer, it will fit nicely in between where the first layer was laid down. See that? It's right in between there. Covers up the blue area. And so I think we'll just keep on going around and fill in the blue areas and fill in this toroid, and it should be pretty nice when we get done. Okay, so that should about finish off the second layer. And see how the first layer and the second layer just go in between each other on the outer edge. I'm trying to keep the coils tight. So that should be about 30 turns. And maybe I'll tape this off and then start another layer. Beautiful, huh? Okay. So anyway, here's our inductor, and I think I'll just go around it with some electrical tape. Tape it off, keeping all the windings tight. All the way around. Okay, so it looks like we're able to get about 12 turns around on the third layer of this guy. And I'm going to put a fourth layer that will go in between those. And the hole's starting to close up, so not sure how many more turns I can get through it, but we're getting close to the end maybe. How exciting. Okay, so it looks like my guess of feeding about half the spool through was pretty close. I have enough lead on the other side. I'm going to cut them a little bit long because you can't ever cut them short, right? Make them longer once you cut them short, I mean. So this is around, what, between 50 and 60 turns. I think about 54 I was estimating. And maybe I'll tape this guy up and cut the leads, and I think we'll be ready to test them then. It'll be very interesting. Okay. Well, it's a work of art, huh? Okay, so we have our inductor here, and I stripped the wires back so we could do some testing with it. And we have our LRC meter here, and it looks like we're measuring about 572 microhenries for one of the windings. And we'll do some testing to make sure this transformer works okay. Okay, so we have our, this is one of these cheap piezo speakers, and I hooked it up to the blue winding of the transformer, and I'm inputting the signal generator at 10 kilohertz, and we'll just touch the leads and test this thing out. And it looks like the transformer's working pretty good. Let me bring it down in frequency. Okay. Wow, looks like this is like 90 hertz. Let me put a sine wave in there. Okay, so that's 90 hertz. Okay, so that's like 10 kilohertz. Okay, and you can't hear that. It's like 200 hertz. It looks like it has response pretty far down in the spectrum. Okay. Let me just maybe I'll hook up an oscope to this, and we'll just see how this behaves. Okay, so we have this set at about 90 hertz, and we'll just see what the frequency response is. Let's bring it up 200 hertz, 300 hertz. This is 700, 800, 900. Okay, so that's a kilohertz right there. Okay, so let me bring it back down, and I'll put it on the kilohertz scale. Let me, this stupid scope will turn off if I don't do something. Okay, so I have it on a kilohertz scale, and there's 2 kilohertz, 3 kilohertz, 4 kilohertz, 5, 7, 8, okay, 9, 10, 11. So it looks like the response is pretty high. That's on the 2 volt per division scale. Okay, so that's the kilohertz. Okay, and so we're at 9 kilohertz. I just went up to the next scale, 9 kilohertz. And let me again fiddle with the scope for a second, because it will shut off. 9, 11, 12. Looks like I'm going to go off scale, so I'm going to have to change this to, let's see, 5 volts per division, okay? So we're again at 9 kilohertz, and I'm going to start bringing it up. 9, 11, 19, 20, 26, 38, 40, 50, 60, 70, 80, 90, 100 kilohertz. Okay, so we got a frequency response up to 100 kilohertz there. Let me go up to the next scale here, and we'll start at 90 kilohertz. Okay, and we'll see how high of a response that we get out of this. It's 400 kilohertz, 500, 600, 700, 800, 900. That's megahertz, 1.1 megahertz right there. Okay, and again, got to figure out a way to keep this thing on longer. Let me go up to the 10 megahertz scale, and we will see. Okay, so we'll start out 1 megahertz, 2, 3, 4, 5, 6, 7, 8. Okay, it looks like it's starting to drop off. There's 9 kilohertz, or 9 megahertz, I'm sorry. So 8 or 9 megahertz is where it starts to drop off. We're at 8.9 megahertz right now. We're at the max of what this scope will do. Let me turn it back down again. Okay, so there is 3 megahertz, 4, 5, try to find the cutoff. So about 5 megahertz, it looks like, is where this thing really starts to cut off. So I'll just do a sweep through the whole range so we can get a good picture of that. So what did I say, 5 kilohertz? Or 5 megahertz, I'm sorry, why am I saying that? 5, that's 5, that's 6 megahertz. So still got pretty good response up to 6 megahertz. So 6, 7 megahertz is the upper end of this. And let me go back down again to the kilohertz range. And it looks like bringing the frequency back down. So about 2 kilohertz is where it really starts to drop off on the lower end. So 2 kilohertz to about 6 megahertz is the bandwidth of this transformer. So not too bad, huh? Okay. Anyway, very interesting. So we'll have to use this for some experiments coming up. Okay, so here we have a high power speaker. This is the pyramid speaker. I did a little video on the frequency response of that, our high power transformer. This is a circuit that I showed how to simple high power switching supply circuit. And here's some lithium batteries. I have 4 of them in series, so that's about 16 volts. And I'm powering it with my power supply here. I got everything wired up. And we'll just put some high power through our transformer. And it looks like it's capable of sustaining. This is about 16 volts over here. And the speaker's about 4 ohms, so that's about 64 watts going through this guy. And I'm sure it can do a lot more. The speaker's capable of handling 300 watts, but I'm just going to test it up to that power level right now. So it looks like I'm sure this power transformer can handle that much power too, probably for an extended period of time. Anyway, very interesting, huh? So looks like our transformer success, a very broad band from like 1 kilohertz up to about 6 megahertz, and capable of putting out high power. Okay. Anyway, this is Dr. Janes, and thanks for watching.